For most of the 20th century, the deep Pacific floor was described in scientific literature the way a desert is described in a travel warning: vast, empty, and without history. That was the consensus. That was what the textbooks printed. Then, in 1985, a dive instructor descended 40 meters off the coast of Yonaguni Island in Japan and found right angles on the ocean floor. Not smooth curves, not natural gradations, right angles, the kind geometry produces when something is cut deliberately with intention. Suddenly, the ocean floor was not empty anymore, and the question no one had budgeted for in any academic calendar was now open. What and who had been down there before the water arrived? Subscribe now or lose the thread. The algorithm buries this kind of content. Pin it down. The answer requires moving through 4 stages of evidence. We begin off the coast of Japan, where a marine geologist named Masaki Kimura spent 15 years documenting what that dive instructor found. We move to Micronesia, where processed stone blocks appear 80 meters below the surface. Stone quarried 200 kilometers away, further into the open Pacific. A 5-kilometer stone road and tiered platform structures have been documented between the Marshall Islands and Hawaii. And we end with the glaciological record, which tells us exactly how old these structures have to be. If you watched Jacques Cousteau's ocean documentaries in the 1970s and felt the seafloor was the last genuinely unexplored territory on Earth, you were right in ways even Cousteau may not have anticipated. The ocean floor was not only unexplored. In places, it was inhabited. The assumption that organized human civilization began 5,000 years ago depends entirely on nothing significant having occurred before that date. That assumption is carrying more weight than it was designed to hold. The first stop is Yonaguni. The first fact arrives immediately. The main terrace of the Yonaguni monument measures over 150 meters in width, is divided into precise horizontal tiers, and contains right-angled corners that do not occur in naturally fractured mudstone of its type anywhere in the geological record of the region. That is not an interpretation. That is what Masaki Kimura, marine geologist at the University of the Ryukyus, published after 15 years of underwater measurement and survey. Kimura catalogued over a dozen structural features at the site, terraced platforms descending in consistent increments, a triangular depression that bears no relationship to any known erosion pattern, a stone road running along the base of the main formation, and most significantly, tool marks, parallel incisions in the rock face, consistent with cutting instruments, spaced at regular intervals along surfaces that face upward and outward, not inward where a natural fault break would express itself. The natural erosion argument has been the default academic response since the site was first reported. The reasoning is coherent on its surface. The Yonaguni area sits on a fault line. The rock type is a fine-grained mudstone that cleaves along natural horizontal planes. And what looks like engineering may simply be what happens when seawater and seismic activity work on vulnerable stone over thousands of years. It is a reasonable hypothesis. Stop and consider what a right angle actually requires. Erosion rounds. Erosion smooths. Erosion works in gradients and curves. The 3 features at Yonaguni that erosion cannot produce are 90-degree corners where 2 surfaces meet at precise intersections, consistent horizontal layering of the same relative depth across a formation spanning more than a city block, and the tool marks, which are not random surface damage, but repeated parallel incisions following deliberate spacing. These are signatures of intent. They are not signatures of water. Kimura's published position is that the Yonaguni monument represents a combination of natural rock formation and human modification, not carved entirely from raw stone, but shaped, directed, used. The distinction matters because it changes the central question. It is no longer simply did humans make this. It becomes what were humans capable of, and when. The site currently sits between 20 and 40 meters below sea level. The last time that depth was dry land in that part of the Pacific was approximately 10,000 years ago. That date is not a fringe estimate. It comes from standard sea level reconstruction data, coral core samples, sediment analysis, glacial melt modeling that has been stable in the scientific literature for decades. One side can be argued away. What researchers found in Micronesia made that argument significantly harder. The stone doesn't belong there. Neither does the explanation. Off the coast of Pohnpei in Micronesia, at a depth of 80 meters, researchers documented a series of processed andesite columns and architectural blocks arranged in formations that have no natural geological explanation. Andesite is a volcanic rock, dark, dense, formed under specific igneous conditions. The seafloor sediment surrounding these formations contains no native andesite deposits. The nearest confirmed andesite quarry is on the island of Kasre, approximately 200 kilometers to the east. 200 kilometers. Across open water for stone that weighs several tons per block. The standard explanations that typically absorb anomalies, like this one, seismic displacement, volcanic deposition, coral accretion. Mistreat a stonework fell here on the specifics. Seismic displacement moves rock, but does not produce organized rows. Volcanic deposition does not quarry stone from a distant island and arrange it in geometric formations. 200 kilometers. From the source, coral accretion builds outward in irregular organic shapes. It does not replicate the angular precision of cut stone. Each available geological explanation, applied to the Micronesian evidence, dissolves on contact with the physical record. What makes the Micronesian sites particularly significant is their number. This is not a single anomalous location. Multiple formations have been documented across a geographic range, spanning several hundred miles of Micronesian waters. Patterns carry different scientific weight than individual data points. A pattern this consistent, across this much distance, is not incidental. What kind of civilization requires a 200-kilometer supply chain? That is an engineering question, not a rhetorical one. Moving multi-ton andesite blocks from Kasre to Pohnpei across open ocean, with no land route, requires vessels with cargo capacity, navigation systems capable of maintaining course across hundreds of miles of featureless water, and a social organization capable of coordinating a logistics operation at that scale. Each requirement implies the others. You cannot have the stone transport without the ships. You cannot have the ships without the navigational knowledge. Neither can exist without the civilization that built, operated, and sustained them. The depth of these formations connects them directly to the glaciological record. At 80 meters below current sea level, these sites were coastal terrain approximately 10 to 12,000 years ago. The sea level data for that period is among the most rigorously established datasets in earth science, derived from coral core samples and glacial melt modeling independently verified across multiple research programs. What is now 80 meters underwater was, during the last glacial maximum, dry land near the shoreline. Someone was working on that shoreline. Someone was importing stone from 200 kilometers away. The work they were doing was organized enough to leave a recognizable pattern across hundreds of miles of open ocean. That pattern had a center of gravity. In the open Pacific, between the Marshall Islands and Hawaii, researchers found evidence of what that center may have looked like. A continuous stone road, 5 kilometers in documented length, runs at consistent depth along the seafloor between the Marshall Islands and Hawaii. 5 kilometers. In stone, laid at a depth that corresponds to dry land during the last glacial maximum. The road does not follow a natural ridge. It does not trace a geological fault line. It runs in a direction, and roads run in directions because they connect places. Places imply populations. A population building 5-kilometer stone roads was not a temporary encampment. It was a society with infrastructure. Translate that into what it requires. A 5-kilometer stone road is not a village project. It is a civil engineering project. It requires surveying, establishing a line across terrain, and maintaining it over distance. It requires organized labor, sustained over time, directed by a planning structure with the institutional capacity to hold a construction project together from start to finish. It requires, in short, the kind of social and technical organization that archaeologists consistently associate with advanced civilization. The only difference here is the address. The stepped platform structures documented in the same region compound the problem. Tiered platforms, stones, arranged in ascending horizontal levels, each level receding from the one below, appear independently in Mesoamerica, in Egypt, in Southeast Asia, and in the ancient Near East. In every above-water context, they are associated with ceremonial or civic function. Elevated space is built to be seen at a distance, to project authority, to mark the center of a structured social world. What researchers documented in the Marshall Islands region follows the same geometric logic, the same stepped recession, the same deliberate elevation above the surrounding surface. Consider what a coincidence would require here. For these structures to be natural formations, the Pacific seafloor would need to have independently produced, through purely geological processes, the visual and geometric vocabulary of monumental architecture as it was developed separately by at least 4 distinct land civilizations. The seismic and volcanic geology of the region does not support that conclusion. The structures do not match the local geological signature. They match the signature of planned construction. The researchers who have worked these sites professionally are not, as a group, making claims about a lost continent or a mythological golden age. They are making a more specific and more uncomfortable claim that the structural evidence at these locations is inconsistent with natural geological formation, and that the timeline implied by the depth of these structures places their construction during a period when, according to the conventional record, the organizational capacity to build them did not yet exist. That is the precise nature of the conflict, not myth against science, science against itself. But the most unsettling part is still ahead. The question is no longer whether these structures exist. Coordinates have been published, depths have been measured. The question is what the depth means and what it tells us about when the water arrived, how quickly, and who was standing at the shoreline watching it come. The depth at which these structures sit is not a mystery. It is a measurement, and that measurement connects directly to one of the most thoroughly established data sets in Earth science, the global sea level curve, for the last 20,000 years. During the last glacial maximum, approximately 20,000 years ago, global sea levels were roughly 120 to 130 meters lower than today. That is the consensus figure derived from coral core samples, ocean sediment analysis, and glacial ice volume calculations, verified independently by research teams across dozens of countries over the past 60 years. The science of sea level reconstruction is not controversial. It is among the best understood areas in all of Earth science. What was sea levels doing 12,000 years ago? That answer has been settled for decades, at 12,000 years before the present. Sea levels were approximately 60 to 80 meters below current levels, rising at rates that were, in geological terms, rapid. Coastlines that had been stable for thousands of years were retreating by meters per century. Communities built at the shoreline would have experienced, over the span of several generations, the gradual submersion of the world they had built. The Yonaguni main terrace sits between 20 and 40 meters below current sea level. The Micronesian andesite formations sit at 80 meters. The Marshall Islands road and platform structures sit at depths consistent with the 80 to 100 meter range of the early Holocene sea level curve. Each depth corresponds to a specific window in the glaciological record. Each window opens before the conventional origin point of organized human civilization. This is not the fringe part. This is the geometry. The geographic distribution of these sites deserves attention beyond their individual characteristics. They cluster along what would have been, during the last glacial maximum, the coastal zones of substantially larger Pacific islands and landmasses. The Pacific was different then, not by imagination, but by measurement. Island chains now separated by deep water were, in some cases, connected by dry land. The Pacific Basin had significantly more habitable coastal terrain than exists above water today. Some researchers working in this area have cataloged additional anomalies, unusual structural remnants under active investigation, that have not yet cleared the evidentiary threshold for peer-reviewed publication. They are worth watching. They are not yet the argument. The argument is simpler and stronger. The structures that have been documented, measured, and published sit at depths that were dry land during a period when, according to the conventional timeline, nothing like this should have been possible. Something was there. The evidence is the depth. The operating word here is inertia, not kuvera. The academic resistance to the Pacific underwater findings is not, at its core, a conspiracy of suppression. It is a structural feature of how large scientific frameworks maintain themselves under pressure. The conventional timeline of human civilization, agricultural societies emerging around 10,000 years ago, monumental construction beginning around 5,000 years ago, writing and organized social complexity following shortly after, is not simply a date range. It is a load-bearing element of modern anthropology, archaeology, and prehistory. To revise it requires revising the interpretive frameworks of hundreds of interconnected fields simultaneously. That is institutionally expensive. Researchers who challenge the foundational timeline do not face censure so much as frictioned journals, requiring higher evidentiary thresholds, funding bodies declining to support deep-sea excavation with uncertain returns. Peer reviewers applying conservative standards to claims with large implications. The result is not silence. It is slowness. And in underwater archaeology, slowness has a practical cost. Ocean sites are expensive to investigate, difficult to excavate, and subject to ongoing seabed change. Evidence does not wait indefinitely. The Pacific findings are not unique in their implication. Comparable underwater anomalies have been documented at the Gulf of Kamhat off India's western coast, where sonar scanning in 2001 revealed a structured layout at approximately 40 meters depth, corresponding to sea levels of roughly 9,000 years ago. The Black Sea Shelf produced similar evidence. Organized structural remains at depths submerged by the rapid infilling of the Black Sea from the Mediterranean approximately 7,800 years ago. These are not Pacific anomalies. They are global data points, geographically unconnected, pointing in the same direction. What the Pacific evidence contributes to this picture is scale. The Pacific Ocean Basin is the largest single geographic unit on the planet's surface. If coastal civilizations developed along its shores during the last glacial maximum, and the structural evidence suggests they did, then the scope of pre-conventional human civilization was not limited to a river valley or a coastal peninsula. It was oceanic in range. That changes nothing about the physics of the past. It changes everything about the story we have been telling. What the Pacific findings suggest, taken together, is a single clarifying idea. The boundary of human history is not where we drew it. It was drawn at the coastline, at the edge of what was accessible, surveyable, and dry. Everything below that line was assumed to be geology. It turns out some of it was biographer, and that says something about us. Not about the people who built at depths now measured in meters of ocean, but about us. We constructed our entire understanding of human time from what survived above the waterline. We dated civilization by what we could walk to. We are, it turns out, archaeologists who forgot that 71% of the planet is covered in water, and that for most of human prehistory, a significant portion of that water was land. The image that stays is this: a shoreline 12,000 years ago, at the edge of what we now call the Pacific. Someone standing there, looking at a road they had built, watching the water rise with the patience of something that has no patience at all. They didn't stop building. The ocean kept the record. We forgot to ask it. If today changed how you see one thing, the next video will do it again. Subscribe and stay close.